Bismillahirrahmanirrahim. My name is Usman Ubaid and our final year project title was Weldability Investigation of Aluminum Alloy 6061 performed through friction stir welding using different tool materials. My group members are Muhammad Haroon, Ammar, Nasir, Fiza Batool, and we did our project in the supervision of Sir Arsalan Hussain. Here's our presentation outline. First, I will let you know about the brief introduction of friction stirred welding. Then we will talk about our objectives and social economic benefits. And then we will talk about our methodology of research work. And at last, I will show you our project demo. I will let you know about the brief introduction of friction stir welding. So what basically is a friction stir welding is a solid state joining process that uses non-consumable tool to join two workpiece material. Heat is generated through friction of revolving tool which softens the region near the tool. Our main objectives. We use tool with different material and geometry, and after performing friction stir welding, we will investigate properties like weldability, temperature distribution, and stress distribution both experimentally and through simulation, and at the end we will compare both the results. Some of the social economic benefits of friction stir welding are: firstly, it is environment friendly. It don't produce any toxic fumes or modern sweat. Secondly, it uses non-consumable tool with no ferrule wire. And at last, setup cost is low and less training is required as compared to other traditional welding techniques. We divided our methodology of research work in 6 different phases. In first phase, we did our literature review and market survey. In second phase, we installed and learned our simulation software. In third phase, we recruited our material for tool fabrication and aluminum plates for welding. In fourth phase, we investigated weldability on simulation software. In fifth phase, friction stir welding was performed and its specimens were fabricated. And at last, we performed tests and collected its data. Here is our project demo. We used Abaqus software for our simulations. This slide shows the tool on which we did our mesh analysis, having approximately 13,000 nodes and approximately 12,000 elements. And here are our plates, which are finely meshed in the center because our properties like temperature distribution, stress distribution are focused in the center. Plates are having approximately 78,000 nodes and 70,000 elements. Here are our results for temperature distribution that we achieved through simulation. The treating tool is first plunged, then drilled, and then it welded the plates. In this slide, results for stress distribution is shown that we achieve at the end of our simulation. Here are our results for temperature profile along axial central axis. We took 3 points in the center of plates as a reference and recorded its results at the initial stage, mid and the final stage respectively. Here are our results for stress profile along the axial central axis, and we took 3 points in the center as a reference and recorded results at the initial, mid and the final stage respectively.